Just to talk you through practical 10, which we know is going to come up, I'll do recrystallization first. So aspirin made using ethanoic acid and ethanoic anhydride. If you're asked why other alternative reactants are not used, it's because they're more corrosive. So obviously we use less corrosive reactants if we can do. What do you do with the crude aspirin? You dissolve it in a minimum amount of hot solvent, so the aspirin recrystallizes when cooled. If you use too much solvent, then it won't come back out of solution when you cool it. At that point, insoluble impurities are filtered out because the aspirin will dissolve and insoluble impurities don't. The filter paper is wet, so the air passes through the filter paper rather than around the sides of the filter paper, and then the aspirin dissolved in the solvent goes down into the flask. The flask is cooled so that less aspirin can dissolve and therefore recrystallizes, and the cooler the flask, the more aspirin recrystallizes and the greater the yield. The solid aspirin is filtered out and now remains in the filter funnel. Aspirin is washed with distilled water to remove any insoluble impurities, which will then go down into the flask. The water will be the main impurities. The aspirin must be dried, and the way that they recommend to do it is to press it between two pieces of filter paper. The purity is tested by using melting point apparatus, and the purer the aspirin, the closer its melting point is to that of the pure aspirin. So every time it gets impurities, or the cruder it is, you could say crude aspirin means impure aspirin, the cruder it is, or the more impurities, then the lower the melting point down from the data point melting point of the aspirin. The sharper melting point means that it's purer, and obviously if it's a white solid such as aspirin, the whiter the aspirin's appearance and the larger the crystals, then the more pure it is. It may not be aspirin. It might be something like paracetamol, it might be something like benzaldehyde, it could be another solid, but the process is exactly the same. Now there's another part to this, reflux. If you are reacting two liquids together and then separating the product of the two liquids, you might have to heat the liquids together for a prolonged period of time. So you put them in a flask, and you use a condenser pointing upwards with the water coming in at the bottom, and the idea of that is that as you heat it, then any gases will condense and drop back down into the flask and carry on reacting. It's a way of ensuring that your reactants don't escape as gases. You need anti-bump granules in there to stop big bubbles forming. And for flammable reactants, then you'd use a water bath. You wouldn't heat it directly using a Bunsen burner. And if you want to get it additionally hot, so maybe you need to heat it up above 100 degrees C, then you could use something like an oil bath. How do you separate two liquids then? Well, if they've got different boiling points, then you can heat them up in a round bottom flask and distill them. The bulb of the thermometer, if you have to draw it, should be level with the outlet, and cold water goes in at the bottom and out at the top. Separates liquids based on their different boiling points. Say, for example, if it was ethanol and water, you need to heat it at above the boiling point of the first liquid, that being ethanol in this case, above 80 degrees C, but below the boiling point of water, otherwise both liquids would distill across. Heat the mixture, and the liquid with the lower boiling point will boil, turn to a gas, condense in the cold condenser, and can be collected. If you want to maximise the yield of the product, carry on distilling until no more liquid condenses, but I would cool down the collection vessel so that you get increased yield. If it says how do you remove water, then you could shake it with something like a drying agent, something like sodium sulfate will remove the water, and then if there's acid in there, you can remove it by shaking with sodium carbonate. You know that carbonates react with acid and make carbon dioxide, so that would do that. Any immiscible liquids can be separated using a separating funnel. One liquid might float on top of the other. That's called two immiscible liquids. That's when you'd use a separating funnel, open the tap, and release the less dense of the two liquids. You could also decant it, so pour the top layer off just by pouring it from a beaker, but that's less successful. And that's that really. Just make sure you know about diagrams, so look at diagrams as well. Make sure any open ends are left open Any seals between flasks, and say for example a condenser touches the line so there's no gaps, and use a ruler and a pencil. And again, for this one, bulb of the thermometer level with the outlet tube. Look at the conical flask, there's no top on it, so that's an open end, whereas everything else is closed. And similarly for the Buchner funnel, yeah, that's how you draw a Buchner funnel. So for vacuum filtration, make sure everything's sealed in this case. And you can just draw a line across with moistened filter paper. And the top part, it comes in two sections of Buchner funnel, so you can draw a straight line going across because that's perforated with holes.